I feel like all the lead mine's like run out too, don't you?
Oh wait, is this a pen?
8 a.m. math feels
Oh, I think
weird.
that's a pencil. I see
8 a.m. anything feels weird.
No, 8 a.m. English is like a different
Hit.
little like
Yeah.
world.
I
It's
know,
it's
different
different.
They're all very
Yeah.
I love 8 a.m.
I was
English.
gonna say, out of all the classes, the only one I could actually probably do at 8 a.m.
That's the only class.
Did you see
that
my
I-
second?
That's the only class that I would like having at 8 a.m. But I don't think I'd like it if it was at any other time of the day.
Everyone here is singing
If it was like in the afternoon, I'd hate English.
So you're not enjoying this?
No. I like math last period. Like I just like that's always what it's like been.
and in the same seat as
I've always had math in the afternoon.
I have.
It'll be that way from now on. Okay.
Do you have somewhere?
What do you mean?
So,
I'm just gonna wake up and it
Oh, wait.
makes me want to die every day.
Wait, actually, I might have blood though.
okay, girls, listen up. I will let you know most likely next class on Friday when our test will be, because I think we're due a test on trig graphing, but I'll have to look at the syllabus, which I've barely done since I got back. But
Yeah, Ava.
I'll let you know.
I might have blood. I have one piece of blood.
Next class, there will be a memo page quiz. And you know, we'll have time this semester to have a lot of them. You know that I'm not completely sure that I'm gonna count your best 5. I may count more than that if we take a whole lot. But it'll be a nice proportion of ones that you can drop and ones you can count.
They still go to the
Um,
test.
Yeah, which is great. It was really fun to put that score in along with the other
I can
scores.
imagine.
Yeah, but I continue to do it every year because it's so effective to what my goals are to get you to do as a good pre-cal student, and so it's so rewarding for you. But you know, I know it gives you the drive, and also what's great is I notice every year people, once they hit their good score, they still keep trying, which is what I like. Because a lot of you just got back papers that you really didn't need the hundreds on. So I appreciate that. But it's good for you, it's not about me.
Do those that we just got back?
They were on last semester. Question, was that it?
Yeah, that was.
Okay. All right, now let me review graphing, secant, and cosecant, and so you can just kind of put that aside for a minute or write on the back of it if you want to write anything down, or you can just watch me because I think you'll remember it. I think QuickTime is going. So I record every class, and you can look in class notes. If you can't find something, just ask one of us. Did they give you a textbook?
What?
A book?
No.
They have a book. Okay. I'll try to remember to bring one to you. Or if there's ways to get one online, but I can't tell you because I think it's illegal. So anyway, if you have why,
Fix the board with the right hand side of it.
Yeah, I can't believe we've
You
been
know,
doing
when
it
you
for that
put
long.
the
Yeah, like that
drawing
half the board.
where, like, it
is
didn't
so
really-
should I move over here?
No.
Oh,
like
wait, wait.
the,
Oh,
When
when
you
you
write
write
it
on the
through on
board.
the
No,
more
did they
right
fix
hand
the
side of the board,
coordinates?
it didn't really match up with where you were drawing.
Right.
I just was wondering if they fixed it, sorry.
I just never ask them. I never
Oh.
remember. I leave and I go, and today maybe will be the day. All right, y equals 3 secant x. All right, you treat it like 3 cosine x. And let me ask you before I go any further, because I don't really remember. I should look back at my syllabus. Did we graph tangent at all before the holidays? Okay. All right, so we stopped with this this stuff.
Yeah.
Okay. All right, so 3 cosine x. And so our amplitude of this is 3. The stretch or the number in the front. Secant graphs don't really have amplitude, so technically I should call that stretch. I'm not going to do this to you on a quiz, but if I asked you for the amplitude of this on a quiz, you should actually say there is none, okay? What the 3 does is these little U shapes, that it's going to make, the 3 will actually dictate how far apart they are. All right, that causes a stretch between your U-shapes. Do y'all see what I mean? If the number in front is small, these little U-shapes, a cosine wave with a small amplitude would have been the pattern that you followed. A higher amplitude in front of cosine results in the reciprocals being further apart, so it causes a stretch in the graph. Does that make sense, or I could show you on Desmos? Okay. Why does it not really have amplitude though? Because technically by definition, amplitude implies a graph that actually has an amplitude. Amplitude is how far it varies from the norm, okay? And these go off to infinity. Sine and cosine are the only two graphs, trig graphs with amplitude. In fact, sine and cosine, I don't know, let me think. They might be the only graphs with amplitude. To actually have amplitude, it needs to go off for infinity and go up and down a contained amount. And you already know that we use them to model many things in the real world. Okay. All right. So anyway, after all that, this is nice. The period of this one that I just made up is 2 pi over 1. The count. Are y'all okay with 2 pi over 4 or pi over 2? Phase shift is 0 and vertical translation is 0 because nothing is added or subtracted. Bryn?
And the count is pi over 2b 0 divided by 4, right?
You take the period you just found and divide it into 4 equal parts, always and forever. Okay, even the day on tan and cotan. All right? Now, you know how I circle that and say that's your starting place, okay? That'll change a bit on tangent in just a little while, but we'll talk about that. So what I'm going to do is I'm going to start at my target. Okay, oops, there goes the board. All right, which is 0, 0. I'm scared to hit undo because it might undo everything. Oh, okay. All right, so I'm going to start at my target, which is 0, 0. And then I'm going to count out pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2 for a period of 2 pi. And then since it's cosine, I'm going to start high at the amplitude positive 3, back down to the middle, down 3. Y'all are great at graphing, labeling. I don't have any complaints about that. Now that you're really trying to graph secant, you need more points than that. I just went through one period, high, middle, low, middle, high. That makes sense to everybody so far? Kind of jog your memory of, before. All right, then get a few more going to your midline. Like I'm going to go down 2, 3, 4. So I go to middle, low, middle, high, and there's one back here too. If you like, you can dot in cosine, okay? Don't draw it in because you're not supposed to be graphing cosine, you're using it as your pattern. Everywhere it hits the midline, you have an asymptote. And so I'll dot in cosine for this moment. Boy, I put that way far back there. I'll blame it on the board. Okay. Everywhere that it's 0, it hits the midline, you have a vertical asymptote. That's where it would be undefined. Because wherever cosine is 0, the thing we're trying to graph, secant, would be undefined. Y'all know the reciprocal of 0 is undefined. Okay? Then you meet your amplitude, and you learned to draw the U-shapes after your first night's homework on this, to fill up that space. However far apart these asymptotes are, dictates how wide those U's should be. Oh, I can't grab that. There. If that's skinnier, your U's will be skinnier. If those vertical lines are further apart, the U shape should be further apart. Okay, oh, there's one more back here according to my graph, and then I'll take questions. All right, so secants and cosecants actually are super weird. They look like this, okay, with a bunch of asymptotes in them. They're undefined frequently. Julia.
For taking a test on this, how many points should we graph?
I'll say graph through at least 2 periods. And so find one, and then what I did, you don't even have to keep labeling, but kind of go out 4 more in the same distance, of the same units I measured.
Yeah.
You don't have to keep labeling, but I think it also makes us all feel better to have a little bit more to look at. Okay? Now, another thing, and then I'll get Bryn's question. It's fine with me if you don't dot in cosine, if you don't like a messy picture. You could go, that's my starting place. Start, middle, low, middle, high. Everywhere it's a middle, you could do your asymptotes. You don't actually have to put the dotted sign or cosine in, okay? But it's just up to you. Bryn.
Shoot. Oh, yeah, so when we're graphing 2 periods, can we just do it in the positive? Or do we have to go into like, you know?
I like for you to go back, if it's already in the positives, I like for you to go backwards across the axis, but that's
Would we have
not
to, like-
necessary. I wouldn't count off.
Yeah, so we wouldn't have to would we have to write, you know, like the count and the period, like pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2? Like, would we have to go back and
You don't
do
have
it?
to keep labeling, but they
Okay.
need to be the right size.
Got it, yes.
Okay, kind of like I did here. All
So
right.
we have to write 4, and then you can make a few more lines, like a line.
Possibly 5 if your starting place isn't 0, 0.
Oh, yeah,
Okay. Okay. So, I mean, I don't even know why I made this one up to start with, because it probably would have been better had I done a phase shift and a vertical translation. But I think you're all at a point where you don't really care where I start. You know, y'all seem to take really well to getting your common denominators and adding. So what I did here was I added my count to whatever my phase shift is. I just happened to make up an easy one to start with. Okay? All right, now, any more questions? But that kind of like talked about everything we learned with sine, cosine, secant, and cosecant. Okay? Obviously, the most applicable of the graphs as far as real world vision is concerned, or like how this is working for Alexandra and myself, are sine and cosine, because those are the sound waves, electromagnetic waves, microwaves, sonar waves, radar waves, you know, all of those things are really modeled with sine and cosine. That's how those things work. The reason I really need the graphs of the other one is more algebraic. You know how there's so many times you look at a graph of something to decide where it intersects the y-axis or something like that. So there's not really a lot of real, you wouldn't see a cosecant wave going through the air with some kind of machine that I know of yet. I mean, who knows? So I read an article yesterday. There's been a lot of articles lately about if there's extraterrestrial life. You know how things come in waves in the news and they get on some sort of kick, it looks like.
Yeah.
But I read something about an astronaut that was saying that he firmly believes that there's life on other planets, because the galaxy, I mean, as far as we know, this just blows my mind that it's infinite out there. It's just crazy. But anyway, so there's like, why wouldn't there be, was his premise. But he said he even believes they're here, but we can't see them. And I thought, okay, I'm going to stop reading now. But don't you wonder, I mean, what if somebody had said, I've said this to you before, hundreds of years ago, like, there's these waves going through the air, but you can't see them. And one day you'll be able to use those waves to talk to someone. I'm sure you could call your family in Brazil on the phone. You could text them. And I mean, it's instantaneous, and it's all based on these mathematical waves that we really can't see. I'm not saying that there's E.T. is in the room with us, but I don't know. It just kind of reminded me of the things at first we think are crazy, and then we're like, oh, wow, that's kind of weird. There's a lot of weird stuff out there.
I remember there was like 2 scientists that did a TED Talk, and they were talking about how the chance that there isn't, you know, some sort of life out there is like so ridiculously small that it'd be ignorant for us to think that.
To think that there is, or think there's not?
To think that there isn't.
Isn't.
It's just so big, it's like impossible for there not to be something.
No, but
That's so scary.
it's creepy.
I was thinking that
He like
movie
does the
we watched
math.
that was
He
like-
does the math and stuff like
Yeah.
to find the actual like percentage.
What was
Like,
the one with Jodie Foster in it that we all watched?
oh, Contact, such a good movie.
And at the end of it, she was
Oh,
like,
there.
"Look
Do you
at
know?
all
Have I
this
not
is
talked
made
about
up."
that before? Contact has so much
Did we
math
watch
in it.
Contact?
It's-
Like,
yeah,
so
we watched it
many
on
times.
eighth grade.
Why did we
We
watch
need to watch
that?
it this year. It has
We need to watch
so
it
much
this
math in
year.
it. But I'll drive you crazy pausing it and telling you the
No,
math.
I'm fine with that.
We
I
just
am
watched
just such
such a,
a
like,
it's so good.
Yeah, it's so good.
I think it's
I
fine.
remember coming home.
I
from
got a
school
little
and
too
watching
weird
it.
at the end, but
No, but I love
Yeah.
I watched it again.
I feel like
Me too. I watched it
retreats,
4 times.
I think it's nice to watch like those educational movies. I think it's nice that they're
like
made and
Hidden
everything.
Figures.
But if
and-
it's a retreat and we're bonding, I feel like we should watch something that we can all
Oh,
laugh
that
at.
was- I like
together.
No, but one time
And
I
enjoy
We've seen
it
it so many
more.
times.
Like I think they're good movies. Like
That's
we
true,
watched
but I
what's
like
called
it.
Hidden Figures, which is
That
a
was
really
great.
good movie.
When did we watch it?
And it's not a bad
Last
movie. It's
year.
just about like
And then like 2
I
years
like it.
before
That
that.
place is haunted.
Because
Because everyone goes to bed being like,
We were supposed to watch Dead Man Walking.
Instead of
but
laughing
that was
at
scary
it.
for us.
Okay, so anyway, so let's talk about tangent. And if you brought your calculator, please get it out for me now. Put it in, let's do radians. We could be doing all of these graphs in degrees and going 90, 180, 270, whatever, 45, 30s. The reason that we don't, that I've told you before Christmas, is because you would have to make your window so large to see 360 degrees worth of a graph. Radians are just a whole lot more convenient, plus when you'll use them in calculus. Really almost without knowing it. What's interesting is there's this thing called a derivative that tells us engineers about the rates of change and stuff. And the derivative of sine happens to be cosine. You'll learn that next year from your calculus teacher, but the derivative of sine is cosine. And that's only true if you're in radians. If you're in degrees, that derivative is something more inconvenient to say. So then people go, well, I'll just work in radians. But a lot of times you don't even know that you are. Case in point, what's the circumference of a circle? 2 pi r. You were already working, what's 2 pi? Now I hope your mind
360.
sees all the way around. Yeah, circumference of the circle. Okay, so you were already working in radians and you didn't even know it. Okay, tangent. So let's get some points. I'll start at 0, 0. I don't know why this board has to go back to that little skinny every time. All right, so those of you that got your calculator out, let's just grab basic old tangent theta or tangent x, you're in radians. Let's go into y equals tangent x. Have you done any of them? Does it sound familiar or really different? Really different. Okay. Well, they're just learning this now, so you'll at least learn this one. Okay, so tangent of 0. Go to table. Go to table. Y'all know how we go to table and fill in numbers?
Yes.
Tangent of 0, did you get 0? Okay. Okay, right now you should thank me that I did not hand you a sheet with tons of 6 problems with 20 points to find. Remember that day when I did it with sine and cosine? Again, to make the point of I desperately want to learn how to do this and just find 5 points. We're going to be able to just find 5 points and do tangent, but right now we're going to do that tedious exercise altogether, okay? So put in another normal thing. Put in pi over 6.
It's the same
5
thing.
No,
No,
it's
it's not. Never mind.
5.2 and then 5.7.
I looked at the
No,
wrong thing.
0.52 and 0.57.
Yeah.
Okay, I need the y values, 0.57.
0.57. So
Okay.
0.58 if you round up.
All right, so about halfway up. All right, let's do pi over 4. That should be 1, shouldn't it? Okay. All right, because tangent of 45 should be 1, right? Tan of pi over 6, I think, is 1.7. Did I say that right? Pi over 3. Tan of pi over 3. The next one,
Yeah.
pi over 3 is 1.7. All right, pi over 2. Error,
Yes.
undefined. Okay, so now I just hit an undefined. I can't even put anything. Probably an asymptote. Might be a hole in the graph. Might be a jump. Remember all those undefined things we talked about? So after pi over 2, let's go into the second quadrant where some of y'all are really good at the radian game. 2 pi over 3. So now I'm at 120 degrees. Is that
Negative 1.7.
negative 1.7? All right. 3 pi over 4 should be negative 1.
Yeah.
Okay, this is looking kind of crazy. Would y'all agree?
Yes.
Like, what am I going to do to connect the dots? Okay. All right. So just turn your calculators off and listen. And again, be thankful that I didn't make you find like 20 of them, because they would start to be scattered all over and not really make any sense. Okay. Let me do it this way. Let's see. All right, we're going to do some kind of normal here and look at tangent from 0 . Don't know what's happening. To 2 pi. All right, so there's a tangent graph, all right? They look kind of like x cubes in a way, kind of like a bunch of S curves, okay? But do you see if I start at 0, I get like half of one? It kind of starts in the middle of the graph, if you think of the points you were just finding. So if I back up, oh, by the way, kind of learn on your own a little bit. Right now my window is 0 to 2 pi. Which normally I would see this with sine or cosine. If I don't alter the period, how many sine graphs do I see from 0 to 2 pi?
1.
Because that's the period of a normal sine wave, right? How many tangents do you see? Tangent?
2.
All right, because you're doing it like a
Like
puzzle.
1.5. It's not even.
Is it 1.5 or is it 2?
2.
Isn't it 2 full ones? Because I feel like it's coming through like this little S curve, and I've got half of. Don't even know what that means. Okay.
And then it takes like
Hopefully I could go back. Darn. Is it going to still be there? All right, 0 to 2 pi. We are seeing 2. Sorry, I don't even know what I hit to make all that happen. All right, so if I put in tan x, I am seeing 2. It doesn't make a whole lot of sense. Like most teachers, maybe not any teachers, I've never heard a teacher start graphing it like 0, 0 and do a little half one and then keep going. It makes more sense to back up and get a good start. But y'all all see that you see 2, it's just that you've got halves on either side. So it's kind of a silly way to graph this. You might as well start with one complete picture. And so if I go from negative pi to pi, or let's go negative pi over 2. Do you see it makes more sense to go back a little bit to capture the beginning of that graph instead of just start halfway in the middle of everything? Okay. All right, now I'll come back to that in a minute. All right, so what's happening here is, first of all, I went out to 2 pi, but you saw 2 of them. That must mean the period of tangent, a normal tangent wave, is what? Say it loud, pi, isn't it? Good, 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 okay. Do y'all see the period of tangent must be pi? Because if I see 2 of them by the time I get to 2 pi, so apparently it comes in a lot quicker than sine and cosine. Let me show you why, okay? You know, I always spend maybe too much time telling you why, but when I started as a teacher, I had the constant thought as I was teaching my classes, like, why didn't somebody explain this to me? Like, I would have understood it and liked it a little bit more. If I look at sine, sign, all students take calculus, okay? And so when I'm graphing it, it goes positive, positive, up, down, negative, negative. Do you see it takes a full 360 to complete whatever it is it's doing?
Yeah.
It goes, the y values grow, then they shrink, then they go into the negatives before they ever come back to where they started from. Cosine goes like this, right? It still takes a full cycle to start up high. It'll get, then it'll go into the negatives, stay in the negatives, and it takes a full cycle to come back where it started from. Tangent goes like this. Remember, tangent's positive in the third quadrant. So it goes positive, negative, and then what do you see it do? Positive, negative, positive. Do you see what I mean? It's already done a full, complete cycle by the time it gets to 180 degrees. Whereas this one has a pattern of positive, positive, negative, negative. You got to get all the way around before you go positive, positive, negative, negative, positive, positive, negative, negative. Tangent goes positive, negative, positive, negative. So it's done by the time it gets to pi. And then repeats itself, if that helps, okay? So then people start to get confused. So I teach it in a really weird way, which I'm sure is not surprising to you. So I actually have a picture that I wish I had found before class, but I was too tired getting back in town Sunday night. And we had to be at work Monday, and
What do you guys do on Monday?
Just putting grades and stuff.
you don't even want to know what we did.
Okay.
When I read the schedule to my husband, he's like, "Why are you going to work?" But I liked it a lot better than us doing. I'm being recorded here. I like it a lot better than us doing professional development.
Yeah.
What's that? Just like meetings?
That's like bonding, I think.
Or it's meetings and you're listening and workshops and reading and we're all like, okay.
Whenever I hear the word workshop, I get like,
Oh,
it just sounds so like.
Remember like writing
Wait, so what's
workshop?
different then about just?
So Monday, instead of, we usually come and like, really, sometimes you spend the day doing stuff you really need to do, meet as a department, meet as a division, which we did. But, let's see, we got here, what did we do? We had to be here at 9, that wasn't bad. And we had a meeting, like with the entire faculty upstairs, and from Salvar, just kind of recapping and talking about who's pregnant and who's had babies.
Did
Yeah.
Mr. Deck have his baby yet?
Yes, so cute.
Do you know his/her name?
I forgot. I could look it up. I could look it up for you. I know it. It's in my email. So cute.
Probably like Bob or something. Just look at his Twitter. I'm sure it's on there.
Oh wait.
Wasn't it Oliver or something?
But
We make the baby our slides next
we had ping-pong tournament.
That's fun.
Then unfortunately Mr. Hill won. I was so mad.
She won.
Yeah, I was so mad.
Yeah.
What else did we do? I mean, we did stuff like that.
Yeah. That's kind of pointless, but.
Yeah. I forgot the other thing. There was another, anyway. Okay, so there's a picture I actually will tell you about that maybe I'll find and share with you. But this is how I teach trig graphing because now we're at the last 2. There's 6 of them, okay? So, constantly hold up my hands when I'm teaching trig graphs when I get to all 6, okay? And I do this. You'll probably see me later in the day forgetting that I've done this on my hand. And I will probably have it on my face instead, like, okay? Yesterday somebody looked at me, another teacher, and I had like blue marker on my
It's
lip.
like Friends.
But I told her, I'm like, one day I was just teaching, I was on like a roll, and one of my students was like, you have a blue marker on your, I had a blue marker in my hand, and they're like, oh, you should go to your face. And I just colored my lips all the way blue and kept on teaching. They just sort of sat there like, I'm like, let's just keep going. So anyway.
It's like,
She went for an interview at Rice.
yeah, first she introduced.
Sorry. I thought you were saying that she loved the guy. She thought the guy wanted like.
Religiously watch
I
Friends.
know, it's not on Netflix anymore though.
I know. I almost cried.
I don't remember.
It's so sad.
I know, I have
It's
to
a
figure
real
out how to
R&B
do it
moment.
because it's like really weird to not be,
Is it on
have it
Hulu?
always on in the
No.
background.
It's on Hulu for like the premium for like who people who play like the $60 a month to have the live TV.
$60?
thing.
Oh my
So
God.
it's like
You messed it
I
up.
only have
No.
the no ads one. I also
Yeah, that's what I have.
there's like regular no ads and there's like premium with every channel ever and you
Like
pay like
live
$60 a month, which is
then
like
you should get a
ridiculous.
TV.
Yeah.
I'm also today.
Okay, great. Now that I wrote them on my hand, I messed them up. So I'll write it up here. All right, here's my hand. I have these letters on my hand, but I wrote them in the wrong order. All right, so here's my hand, my thumb. There's my fingers. And here's my other hand. There's my thumb. And there's my fingers. Okay? Make my fingers really long.
Why is that so weird?
Is anyone else's pinky just so far away from the rest of
I'm pretty sure I
Oh,
broke my
goodness.
pinky when I was little, and like
Yeah,
it's just
mine is.
messed up now. It doesn't
It's a
straighten.
phone and like a
Yeah.
piano thing and it just makes your finger in the
No,
keyboard.
my pinky like doesn't
Look
straighten.
at mine.
Oh my god, Dakota.
What?
It's really
No, but
if
mine
you
goes
get
like
this.
that.
Stretch it like
I feel like compared to the rest. Why is he coming gross?
Mine
I
is
just
Yeah,
look
no,
at
they're straight. Yes. Yeah.
I just look at my
Okay.
finger when I was younger and now it does this.
Yeah, I'm gonna
All right. Ooh, that's kind of like
I can do
Ava's.
this.
Ava's is all
What
weird.
is that? Who?
Oh, I
Can
can't
you do
do
this?
I can't do
But I can do it.
With all the stuff for my pinky and then they like
Oh,
pop.
I
Wait,
better
look,
not.
my pinky
Okay,
can like.
I just look at my
Okay,
finger when I was
girls.
younger and it does this.
Sorry. I never
All
had
right.
one, but
Well,
I
my
was
fault.
about fingers like that.
It's gonna get more interesting in just a minute than you can imagine. Okay?
What do you know?
Oh my gosh,
Are you
leave it now.
Oh
Wait,
my
it's
gosh.
usually-
On
Okay.
Okay.
You were gonna miss
Or we'll
all
wait.
the-
How far, are you just going to that one?
Yeah.
We'll just talk about our fingers
Okay,
until
I'll
you
give
get back.
1 second.
Continue talking about your fingers. Okay. Can
My
y'all,
fingers
what
pop
is
out,
that?
I can
Broke
probably
it.
cure.
Yeah, I can do
It
that.
doesn't straighten.
But look what my finger does. It does this. I dislocated it
It's
when I
just
was
weird.
little,
My
and I never
whole
got it
family's
this.
like really
So now I'm just.
confused.
Ah!
Look at Ava's.
It just doesn't straighten. It's
Yeah,
really
oh my
weird.
God.
Yeah.
I have
Crazy.
such weird fingers. Ready? So this
Here,
one is
fill
like
mine.
this. It's
Put
like
your
this.
finger on my
Look.
nose.
Look.
Oh,
This
that's
one's
a
like
nice
dead
scratch.
grass. And then this one
It's
goes
like
like
when
this.
I remember when I was little, I thought I could
Yeah.
do this thing up where I can just do this.
No.
Like this thing.
Like,
Everyone
it's
can
like
do
broken.
it.
From
But
the
it's
inside.
really so much
Oh,
bigger
I
than
can't
mine.
look at it.
These are not everywhere.
This looks like a tan.
I feel like I
tan
broke
with
it.
like.
I have baby hands.
Actually.
When I was in second grade, I accidentally stabbed myself with a pencil. Do y'all ever done that?
Yeah.
Yeah.
You still
so
have
you
a
can
mark
still
in
see
it?
the
I
lead.
sat on one
Yeah.
once. Like
I remember,
That's
I
all.
don't know why,
I
but I
got
have like a really,
yeah.
really distinct memory of watching a like bullying movie in
Yes,
like,
Clarissa stands
I
strong.
love like,
Hannah,
I
I'm
love
down.
that
with the
movie.
pencil and it's like connected to a string or something and then she like moves it out.
They push the brother off the diving board and
Yeah,
he,
that's
like, head
crazy.
trauma.
Okay, Anya's back, so we're back. All right. Okay, girls. So on this hand, I was listening to y'all talk about your fingers, and I messed up my letters. So on this hand, I've got sine, cosine, secant, cosecant, cotangent, all the CSCs. Okay. All right. So you remember that? Sure, Marymount girls, CSCs. Okay. So sine, cosine, secant, cosecant, cotangent, and now I've run out of fingers, and who's left? This is important. Sine, cosine, secant, cosecant, cotangent. Who's left? Tangent. That doesn't fit in with the CSCs, does he? Okay. Tangent doesn't fit in with the CSCs, nor should
Poor guy.
he. Okay. Tangent is the only one of the 6 that our phase shift will be the center of our graph, not the start of our graph. Usually our phase shift is where we start and we count 1, 2, 3, 4 and draw the appropriate graph. That's all we've done so far out to the period, right? Okay? With tangent, you saw what happened. I would go out 1, 2 and run smack into an asymptote and only have half a graph by that time. So what we all teach is here's your phase shift. With tangent, only tangent, this lonely person over here, okay? Only tangent, we count out 1, 2, 3, 4. Some people aren't looking, this is important. Phase shift is going to be the center of the graph, only with this person all by himself over here, okay? So tangent, our phase shift, I feel like it's really makes sense to say, oh, I'm going to start here, but I'm going to count out 1, 2 and get a piece of the graph, and then back 2 and finish my graph. That makes more sense than getting half of a graph and then going forward. Do y'all at least sort of see what I mean? Okay, so one year, I'm like holding my hands up like this, my left hand with my 5 fingers, and this hand had tangent on it, written on it. And all of a sudden it dawned on me years ago, I'm like, I'm so glad that I have 5 fingers on my left hand because this works great. Because I can go sine, cosine, secant, cosecant, cotangent. All the CSCs do the same thing. They look different, but every single one of them we started. And also it's great I have 5 fingers because we need 5 points, right? We need a starting place, 1, 2, 3, 4. Starting place, 1, 2, 3, 4. Okay? It's also good because cotangent, like tangents, period, is shorter. It's only pi. So look at my long fingers. Okay, I have little hands actually, but we'll pretend they're longer than my thumb, okay? All of these, period, is 2 pi. So what you should see on my hand is sine, cosine, secant, cosecant. All of those you know. You're going to learn cotangent today or on Friday, depending on what time we have left. But cotangent, you're going to remember that. You can almost sort of like cheat on your test. Do y'all see what I mean? Because you can look at your hand and go, oh yeah, cotangent's little. Also what's cool is my thumbs are the same. So when I go sine, cosine, secant, cosecant, cotangent, tangent, you can actually always see that image in your head or look at your hands. Tan and cotangent have a very small little period. Not 2 pi, but pi. And doesn't that even almost look like a pi if you can imagine putting a line on top of it? Okay? So you'll know tan and cotangent's period is pi. You can look at your fingers and think about pi. Did y'all get what I'm saying in this weirdness? Okay? But the funniest thing is when I'm holding up my hands and go, I'm so glad I have 5 fingers on my left hand because I grew up with a little brother who only has 4 fingers on his left hand. So it makes perfect sense to me. Okay? Did I've already told you this in my class?
Yeah,
You
it's
told
all
me
for sure.
because Zaina.
Oh yeah, freshman.
Okay, so I don't know why I brought it up freshman year because it didn't have anything to do with what we were doing other than just my stupid stories. But it does have something to do with what we're doing now because he couldn't do it this way, he would have to do it this way because he only has 4 fingers on his hand. But my class, I guess it was maybe your class.
It was.
It was, yeah.
And so you saw the picture, I think.
Yeah.
Okay.
It looks
So, those of you that weren't in the class, I got Zaina to, she was sitting with me after school and she held up her hand like 10 fingers and I took her picture. And I guess it was during lunch. Because then I texted my brother who lives in Florida and I'm like, so I'm telling, the story again about how you only have 9 fingers. And so I need you to send me up a selfie or something. I don't know how you're going to do that. I said, send me a picture. Doing this. And I sent him a picture of Zaina so that he would know what to do. And he's like, manages health, like medical offices, like, I don't even know what his job title is, but he was at a business lunch. And he got his person that he was having a business lunch with to take his picture. I got it right away, and some of y'all have seen it. So anyway, so here we go. Sine, cosine, secant, cosecant, cotangent. All the CSCs. The reason I do this is really big because once you learn tangent, you tend to do cotangent too much like tangent. They look a lot alike. Just like, don't secant and cosecant look a lot alike? Sine and cosine look a lot alike, but they're different. And so I keep cotangent over here with these guys. Tangent's the only one that's super different, okay? What do they have in common? They have the same kind of basic shape, but they have a smaller period. That's the main thing they have in common. Wouldn't you say sine and cosine have the same basic shape? But you don't really compare those. I don't know why I found as a teacher, and all teachers find that once we teach tan and cotangent, students tend to compare them too much and it confuses them to death. It's like trying to go, well, sine and cosine look just alike except for a sine is a shifted over or a negative or a this or that, You just learn sine different and cosine different. So please learn tangent different and cotangent different. Again, the power of this is that I don't have 6 fingers, thank goodness. I have to put tangent over here, okay? Because tangent's different, but they do share that shortness, okay? My brother's also short, so that also works. All right, so now let's actually do one. I think you've seen what it looks like. So let's do something like this. And these can look crazy on your calculator, but y'all aren't dependent on your calculator to graph these. They can look like barcodes on your calculator. They just go crazy, okay? We can change. It doesn't really have amplitude. Y'all understand that based on what we talked about the first of class? They go off to infinity. They don't have amplitude. But this number in the front will definitely affect the stretch of the graph. All right, watch what affects it. If I put in 3, do y'all see it stretches it? Okay? And not only, yeah, and I want you to see it this way. I'm going to put in the point pi over 4 so you can actually see it stretch. 1. All right, y'all see it hitting that dot? Now, does everybody see that?
Yeah.
All right. Then I'm going to put in pi over 4, 3. All right? And right now with an amplitude right here of 1, not a stretch of 1, I really shouldn't call it amplitude. And let me change my window just a bit. Let's step by pi over 4s. Okay. So do you see I'm going to teach you to go 1, 2, 3, 4. And right there's the center. And halfway to the end of the first wave, do you see it hits that number 1? All right, so instead of finding all of those points, I'll have you find the main points that we need. Do you see how it locks on here and then hits an asymptote? So Anya and everybody else, I can stretch the graph with what we're used to calling the amplitude. When I put a 3 here, do you see how it stretches the graph and moves that point to a different location? So just like with sine and cosine, if it was 1, you would go here. If it was 3, you would go here, okay? The good news is you still have 5 main points. You have asymptote, you have a low, middle, high asymptote. Asymptotes are on the ends. So you have asymptote, then you have like a point that you can lock onto, then it goes through the center, another point you can lock onto, and then you have an asymptote, and it does it over and over again. So the good thing is this hand, you still have 5 main points. It's just with tangent, you don't start at the phase shift. The phase shift is your center. 1, 2, 3, 4. Okay, so do y'all see my target right there? That's gonna be my target. Or that I just erased somehow. All right, so this is what we're gonna do. Oh, let me show you cotan while we're here. Cotan, the reason I've been waving my hands in the air, as you see if I go out to pi, I'm sorry, you can't see pi, but here's 3 pi over 4, so it's right here at the end. Do you see there's no reason for me to split up cotangent? Cotangent just goes 1, 2, 3, 4 from my target. Does that make sense? It doesn't divide itself up in a weird way. That's why I put it over here with the CFCs. All right, so let me do a main one and then we'll look at your sheet. All right, so here's tangent. So if I have y equals tangent x, I would say my stretch, because it's not really my amplitude, is 1. The reason it's not my amplitude, it's going to hit 1, but it'll keep on going later on, okay? Amplitude is 1. The period is not 2 pi over. You'll have to switch to pi over for tan and cotan. They're shorter, okay? So the period is going to be pi over that number. The good news is everything else is pretty much the same. You take the period that you just found and divide it into guess how many pieces? 4. Divide it by 4. And then your phase shift and your vertical translation, in this case, is 0. I'll do a few different things, okay? This has always been my target, my starting place. With tangents, little person over here, it's the center, okay? So this is going to be your center. You're still going to count out 1, 2, 3, 4, but you're going to go 1, 2, 3, 4. Out 2, back 2, okay? So here's my graph. I'm going to go right here and put my target. Again, that's like kind of a Miss Lazari thing. A lot of people don't put that X there, but I think you're used to that's your location, okay? And then normally with all these people, including cotangent, I would go 1, 2, 3, 4 and start my graph. I would go 1, 2, 3, 4. With tangent, I go 1, 2, 3, 4. Do you see how it's the center of your graph?
Yeah.
All right. So what you're going to do, Oh, and by the way, the stretch right halfway there is gonna be 1 and -1. Anya was asking about the stretch again, like if that was a 4, then I'd have to go up 4 and down 4 at that's really a 45-degree pi/4 location, okay? At the ends are asymptotes. Sorry, I missed that dot, but I guess you're used to that. That should have gone through that mark I had there. Oh, I'm sorry, I didn't label. Let's label. I'm counting by pi/4s from the phase shift. So I go pi/4, 2 pi/4, back pi/4, back 2 pi/4. And you're used to, from your IOU chart, the tan of pi/2 is undefined. You already knew that. Now the graph backs that up. How far is it from negative pi/2 to positive pi/2? 1 pi. 1 pi,
pi,
like
yeah.
2 pi/, do y'all see what Anya sees? I've gone half a pi one way and half a pi the other way for a total period of pi. Then I get all these crazy wavy graphs from my students, like, you know, I don't know, they get nutso, and you might also be one of those people. So to draw it, the easiest way to get the right looking graph is don't try to get too fancy. Pretend like you're gonna draw a downward parabola, like this. And that you were gonna keep on going and then stop. And then the rest of it is like an upward parabola, so you can kind of do your pen like this, and then pick it up here and go up. And that should have gone right through 0, 0. Obviously, the asymptotes dictate the period of the graph. Then, Bren, like you were asking, I would still want you to count out 1, 2, 3, 4. Put another asymptote, another center. You don't have to label. Once you get me started, I know what you're counting on. Okay? All right, now look at your sheet. And let's do, let's see, I did screenshots of all these, but I don't think I need them right now. I tell you what, before that, let's do cotangent. Y equals cotan x. The stretch, or kind of fake amplitude, is 1. The period is pi/1. The count, divide that period into 4 equal parts. Phase shift is 0. Vertical translation is 0. And this is what you do with cotangent. Don't compare it too much with tangent.
Is that like, why is there?
That says cotangent. I put a 1 there to get my period of pi/1. It was cotangent x. Treat these like all of these people that you knew before, okay? So I'm gonna start at 0, 0 and count out 1, 2, 3, 4. Do y'all see what I mean? Okay, tangent and cotangent are not the same. This will be pi/4, 2 pi/4, 3 pi/4, 4 pi/4 for a distance of pi. Okay? With cotangent, you have asymptotes at the beginning and the end. It'll hit the midline right in the middle.
So with cotangent, like,
Don't split it up. Count straight forward, 1, 2, 3, 4.
yeah, but if you dotted in the graph, it would be like half of 1. So it would just be like the upward parabola kind of thing, right? After the 0, 0, and then like 1 coming up. So like the downward one. No, you talked about that?
It's not gonna be, let me just do it, and then let me see if I'm doing what you say. I know the tan of pi/4 is 1. Girls, listen, tan of pi/4 is 1. The reciprocal of that's also 1. So this one starts up high and then goes down low. And it looks like this. It looks like an upside down, moved over tangent graph, which is why I say don't compare them, because it'll drive you crazy. So do you see how it was easy to get one complete cotangent graph?
Does this one have starting place or center?
Okay, it's on this hand. Those CSCs all start. Yeah, but it's such a common question, Kate.
Yeah.
So all of these start and then go 1, 2, 3, 4.
Okay.
So the only place that the phase shift vertical translation is tangent.
Your pressure.
Is the point at pi/4 1?
Yes.
Okay.
Okay. So
So
it'll
then
drive
at
you
negative
crazy if
3
you
pi
look at them
No,
together.
I mean at positive 3 pi/4, that's 1 also, right?
At 3 pi/4, that's negative
Negative
1.
1, that's what I
Yeah.
meant, yeah.
All right, so don't try to compare them too much. If you have them both on the same graph, it will drive you crazy. Oh, I'm sorry, I didn't realize that one was already cotan. Do you see what I mean? Like, you don't really want to compare these, okay? But I would say, I don't know why students tend to want to make something happen with tan and cotan. When sine and cosine, you know they're similar, but you approach them differently. Please do those differently. All right, so I'm going to sum something up and then hopefully have time for a question or two. Please don't forget your question. I just want to make sure I get this out there. This is what happens with tangent, okay? With tangent, the phase shift vertical translation is your center. So no matter where you are, that's your center, and you count out 1, 2, 3, 4. You go 1, 2, asymptote, back to asymptote. Don't draw those little loop-de-loops, please, okay? But you count out 1, 2, asymptote, back to asymptote. Go back to your phase shift with your pen. Immediately to the right, go up to the number in front. To the left, go down. And then try your best to draw a pretty picture, okay? So tangent, go out to asymptote, back to asymptote, go back to your center, put your dot, immediately to the right, go up, okay? With cotangent, as Kate was asking, and you'll be thinking when you're doing homework and work on this, with cotangent, it's over here. You'll find your phase shift vertical translation, and it's your start, just like all the other CSCs, okay? So this is your phase shift. Count out 1, 2, 3, 4. Do not split it up. So you'll go out 1, 2, 3, 4. When you get to the end, put an asymptote at the end and the beginning and a dot in the middle. I've always taught you to go back to your target, right? Put your pen back on your target, and then don't we always make our decision about sine, cosine? Do y'all see what I mean? Go back to your phase shift, immediately to the right of it. If it's positive, go up, middle, low. Okay? So questions before we go?
There's only one asymptote when you're doing cotangent.
No, there's one of this.
It's at the.
Oh, okay, got it.
Okay,
Yeah.
so tangent goes 1, 2, asymptote, back to asymptote.
Yeah.
Cotangent goes 1, 2, 3, 4, asymptotes at the ends. Okay, good news is your homework, depending on how far I got today, we got a lot done. I wasn't even going to do cotangent, so maybe I shouldn't have. But anyway, the good news is your only homework for Friday is memo quiz, and make sure you bring this sheet back with you. I'm not going to make you do any of them yet because I haven't done a phase shift. I'm not going to make you try that without me. You can try the worksheet if you're wanting something to do desperately, okay? So memo page quiz of whatever's on your memo page right now. And I don't even know what's on there.
It's mostly the same now. I think we added something on the last one.
I think graphing we
Yeah,
added.
I think so.
Okay, so you might have questions about period and amplitude. All right, bye.
Thank you.
Okay, so I'll post that on assignments, and we'll grab some more of these next class.